Hi, everyone. In this video, we're going to talk about solutions to the questions in this quiz about logarithmic functions. Let's start. Question number 1. It's a Chinese National College entrance exam question. So we have f of x, which is equal to e to the power of x when x is smaller than or equal to 0, and it is log of x if x is greater than 0. Which of the following is the collection of all possible values of real number a such that f of x plus a equals 0 has exactly two solutions? Okay, so I guess for this question we can look at the graph. So let me have the coordinates plane here. So it's like we have two functions, y equals f of x, and the other one is y equals negative x minus a. So this one has exactly two solutions. That's the same as the two graphs here. They intersect at exactly 2 points. So let's take a look at the graphs. Y equals minus x minus a. Well, that's just a line with slope -1. Like one of those lines. And y equals f of x. Let's draw the graph. When x is less than or equal to 0, it's e to the power of x. When x is 0, e to the power of 0 is 1. And when x goes to negative infinity, e to the power of x will go to 0. So something like that. Okay. When x is larger than 0, it's log of x. We know that log of 1 is 0. And the graph of log of x looks like this. Okay, now we want our line y equals negative x minus a to have two intersections. So I guess all of the lines here should work. And the critical point is when our line passes through this point, 0, 1. I guess, yeah, let's find the value of a if our line is like that. So the point 0, 1 should be on our line. That means 1 equals 0 minus a. So a is next 1. Oh, okay. So we want the y-intercept to be smaller than or equal to 1. And that's like negative a is smaller than or equal to 1. So a is larger than or equal to negative 1. So the answer is C. What is the value of this power? Okay, so on top we have log of root 3 minus root 2. That's the base. And also here we have root 3 plus root 2. So those two numbers are closely related, right? We know that root 3 plus root 2 times root 3 minus root 2, that is 1. We know that root 3 minus root 2, the power of that number, that's a definition of log, right? That's exactly 2. And now, if you look at this root 3 plus root 2, if you use that as the base, then that to the power of log root 3 minus root 2 of 2, that can be written as 1 over root 3 minus root 2 to that power. But then that's just a reciprocal of the number 2 here, which is 1/2. yeah, here I guess the key point is to see that the product of these two numbers should be equal to 1. Okay, next one. Find value of a such that this is true. Okay. So I see those two logs, they have different bases, right? 2, 4, 8, 16, 64. So let's make them the same. So let's do log 2 to the power 6, a to the power 6. You know, it's a property that log x of y equals log x to the power of a of y to the power of a. You know, we can raise these two numbers to the same power without changing the value of the log. So we do log 2 to the power of 6, a to the power of 6 plus log 4 to the power of 3 of a to the power of 3. Our goal is to make everything log 64. So plus log a squared plus log 64 of a. That equals 5. So we have log 64 of a to the power of 6 times a to the power of 3 times a squared times a. That equals 5. Okay. So we know that a to the power of 12 equals 64 to the power of 5. But that's 2 to the power of 6 and then 2 to the power of 5. That's 2 to the power of 30. That means a equals 2 to the power of 2.5. But that's for root 2. That's the answer. Let f of x be a function satisfying the two properties here. F of x equals negative f of negative x. Okay, so it's like an odd function. And has period to be 2. F x plus 2 is always equal to f of x. We also know the value of f of x if x is on the interval from 0 to 1. Okay. So the strategy is to use the first property to convert this thing to f of something, and that something should be from 0 to 1. And then we can use the second property to compute that number. So now let's first do some estimate of log of 1/2 of 24. What is that? So log 1/2 of 24. First of all, that's negative log 2 of 24. That's negative log 2 of 8 plus log 2 of 3. So that's negative 3 plus log 2 of 3. Log 2 of 3 is 1 point something, right? Less than 2, larger than 1. So this number here is 4 point something. It's between 4 and 5. Yeah, we already have a plan. So f of log 1/2 of 24 equals, let's first use the first property. So that's negative of f of log 2 of 24. Cool. We're using the first property there. And now this number here is between 4 and 5. So how can we make it so that's between 0 and 1? Well, we can use this property twice, right? We can do a negative f of log 2 of 24 minus 4. And then our input here is between 0 and 1. So what is that? Log 2 of 3/2, because it's 24 divided by 16. Now we can use the second property here, because our input is between 0 and 1. So we can just use that property. So it's 2 to the power of log 2 of 3/2. But that's just a definition, right? It's negative 3/2. Okay, so the answer is it's B, negative 3/2. We have a geometric sequence. We know A9 is 13. We have A13 is 1. What is log A1 of 13? So A13, A9, I guess we can keep going, right? We have A5 here. But you see here it's divide by 13. So we need to do divide by 13. Sorry, if we go in that direction, it's like times 13. So we need to do times 13 again. That's 13 to the power of 2. And then we can keep going, to A1. That's 13 to the power of 3. Because, the 13, 9, 5, 1, the arithmetic sequence. So, okay. So now we know A1. So log 13 to the power of 3 of 13. That's definitely 1/3. Yeah, so the answer is A. Log 2 of sine, log 2 of cosine, log 2 of cosine, that's just log 2 of the product of everything. So sine pi over 16, cosine pi over 16, cosine pi over 8. Pi over 8 equals 2 times sine pi over 16, cosine pi over 16. Okay, and later on we're going to use sine pi over 4 equals 2 times sine pi over 8 cosine pi over 8. Okay, so this equals log 2 of, well, we have 1/2 times 2, so 1/2 times 2 times this one, but this one is sine pi over 8. So this is 1/2 times 1/2 times sine pi over 4. What's that? Log 2 of 1/2, that's -1. Log 2 of 1/2, that's -1. And then log 2 of, this is pi over 2. This is root 2 over 2. Oh, so what's that? That's negative 1/2. Like log 2 of that is negative 1/2. So it's negative 5/2. And that's the answer. Let f of x be this thing. Okay. A weird function. If f of log 3 of 10 is equal to 0, then what is f of log of 3? So this log is like base 10. Okay, so here the first thing I notice is that we have the nice relationship between the two inputs. So if you take the sum, that's log of the product, log 3 of 10 plus log 10 of 3. Oh, sorry, multiplication here. Okay, but we see, these two numbers are reciprocals of each other. So their product should be 1. So this is log 1, and that's just 0. Cool. So essentially, it's like we know the question becomes, if f(t) is equal to 0, then what is f of negative t? right? The sum of the two inputs is 0. So, but we see that ft plus f of negative t, sine t, sine negative t, they got canceled out. T to the power of 3, negative t to the power of 3, they got canceled out. So if you take the sum, then that's just 10. So the answer here should be 10, right? The sum should be 10. If one of them is 0, then the other must be 10. Okay, next one. Log x to the power of 3 times y is 15, and log x times y to the power of 3 is equal to 5. What is log of x over y? So I guess we can take the difference here, right? So this log x cubed y minus log xy cubed, that equals 10. So we have log x squared over y squared, that's 10. But that's 2 times log x over y. So this log x over y is equal to 5. All right, next one. 47 to the power 100 is a 168-digit number. How many digits does 47 to the power 17 have? Okay, so the number of digits of a number is closely related to log 10 of that number. So let's take a look. For example, if we have x is a 2-digit number, so here x is 2-digit number. Then if we take log, we see that this log of x is larger than or equal to 1 and smaller than 2. Okay. So now we see the relationship here. Now if our number 47 to the power of 100 is a 168-digit number, then if we do log 10 of that number, so it's like 100 times log of 47, that should be larger than or equal to 167 and smaller than 168. You see the relationship here, the same as this one. Oh, okay. So now we have like a very good estimate, right, about log of 47. Cool. So based on that, we see there's 47 to the power of 17. We have a estimate about the log of that. So log 47 to the power of 17, that's 17 times these two bounds here. Okay. So now we need to compute this number. Let me see, 1.67 times 17. What's that? Okay, 2839. Cool. So it's like 28.39. And on the right, what do we have? To 28.56, something like that. What do we see? It's 28 point something. Again, if we look at our original example, if log of x is 1 point something, then it's a 2-digit number. 1 point something, 2-digit number. And here is 28 point something, so it should be a 29-digit number. So that's the answer. So for this one, we can first do the change of base. So log 3 of 4 That's simply log 4 over log 3. And the next one is log 5 over log 4. You see a lot of things got canceled out. The last one is log n over log n minus 1. But after we cancel out all of the terms in the middle, we have log 3 of n. We want log 3 of n to be larger than or equal to 100. That means n is the smallest positive integer that satisfies this. So n should be just 3 to the power of 100. What's the remainder of n when it's divided by 64? So now it becomes just a number theory question. Remainder of this number when divided by 64. So one thing we can do is to write it as 9 to the power of 50. But then 9 is like 1 plus 8. Now we can use binomial theorem to expand everything, because whenever we have a to the power of 2 or 3 or even larger, then it's a multiple of 64. And so those numbers are totally irrelevant if we only care about the remainder of n when divided by 64. So the only two terms that matter here is the first term, 1, and also 8 times this 50, choose 1. For all of the other terms, the a to the power of 2, a to the power of 3, so they are irrelevant. Mod 64. So what is this? This is 401. But that's just 17. Mod 64. And that's the answer. Right. This, well, what does that mean? I guess if we just take the sum of everything, then we have 100 factorial equals, what's that? P1 to the power of A1, P2 to the power of A2, blah, 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 P25 to the power of A25. Pi, they are just 25 prime numbers between 1 and 100. They're exactly 25 primes under 100 in the increasing order. Okay. So it's like 2, 3, 5, blah, blah, blah. What is A3? Oh, cool. So A3, that's simply the number of 5s in 100 factorial, right? In the prime factorization of 100 factorial. So how do we find that? We can do, 100 divided by 5, 100 divided by 25, 100 divided by 125. Well, that's already 0. So that's 20 plus 4 plus 0. That's 24. It's a nice formula to find the number of prime factor, the number of certain prime factor in like n factorial. The idea is, for example, here we have 20 multiples of 5. And so, each of them will give us a 5. They're multiples of 5. But some of them will give us a second 5, right? Those are multiples of 25. So 25, 50, 75, 100, they're going to give us a second 5. And there are 4 of them. So that's the answer. No number will give us a third 5, right? There's no multiple of 125 in the first 100 positive integers. So yeah, the answer is 24. Okay, question 11. A is a positive root number such that a to the power of a equals 9a to the power of 8a. If log a of 3a equals m over n, then what is m plus n? Okay, so I guess we can do log a of both sides of the equation. So on the left, we just have a. And on the right, we have 8a times log a of 9a. Okay, so a is positive, so let's cancel out the a here. we have 1 equals 8 times log a of 9 times a, but that's log a of 9 plus 1. So log a of 9 and then plus 1. Cool. So we see log a of 9 equals 1/8 minus 1. And that's negative 7/8. But that's 2 times log a of 3. So log a of 3 is negative 7/16. And now log a of 3a is just that number plus 1. And that's 9/16. So the sum of m and n should be 25, 9 plus 16. Question 12. X and y are two positive real numbers satisfying the two equations here. What is x plus y? So the two equations, the two expressions here look similar. Actually, this log 2 of x, if we use another variable, for example, t, as denoted by t, then the expression about x becomes t plus 2 to the power of t minus 4. We know that's equal to 0. But we'll also have 2 to the power of y plus y minus 4. That's equal to 0. Okay. But if you look at this equation, there's only one solution because there's y plus 2 to the power of y. It's an increasing. It's just increasing when y gets larger, when y is positive. So this one should only have one solution. But now both y and t satisfy this equation. What does that mean? That just means y should be equal to t. Okay, so now x plus y. What is x plus y? Well, we know x is 2 to the power of t, y is t, but t is a solution to this equation, right? So the value of this should be just 4. And that's the answer. Find positive integer a so that the following inequality has only one solution. Interesting, because this is a quadratic expression of x, right? So maybe one example is like, suppose this one is just x squared minus, for example, 6x plus 8. Usually there should be two solutions because, for example, if x is equal to 2 works, then x equals 4 should also work because the symmetric. But now this one only has one solution. What does that mean? That means the solution must be x equals 3a. If it's not, then there should be at least 2 in the symmetrical position. Okay. So let's just take x to be 3a here, and what do we have? We have log 1/a, and here is negative 9a squared plus 8. This should be equal to 0. It's the boundary case. So what does that mean? We have log a of 4 equals log a of negative 9a squared plus 8. Okay, so 4 equals negative 9a squared plus 8. And we have a squared. A squared is equal to 4 over 9. But it's positive. It should be 2/3. So yeah, that's the answer. How many positive integers x satisfy this inequality? So first of all, based on the definition of log, this this x cannot be 1. So x should be definitely larger than or equal to 2. Then this log x of 2x squared minus x plus 1 smaller than log x of 2021 divided by x. So we just want this 2x squared minus x plus 1 to be smaller than 2021 divided by x. X2 is definitely good, and 3 and small values, all small values. The largest we can do, I guess, is 10, right? When x is 10, here is just below 200, and here's just 202.1. Yeah, I guess when x is larger, then the right-hand side will become smaller, the left-hand side will become larger. If you try 11, that doesn't work. So I guess just those 9 values. So the answer is 9. A is a positive integer such that the following equation has only one solution. What's the sum of digits of A? Okay, so here's a weird equation, but we see log 2 of x. So I have the idea of just doing log 2 of both sides of this equation. On the left, we have log 2 of a x to the power of log 2 of x. On the right, it's just 6 times log 2 of x. We simplify the left-hand side, we have log 2 of a. We have log 2 of x times log 2 of x. Log 2 of x squared. Now we see what's going on because this is a quadratic equation, right, about log 2 of x. We wanted to only have one solution. That means, well, maybe let's rearrange it first. So if t is log 2 of x, then we have t squared minus 60 plus log 2 of a equals 0. Okay, so we only want one solution. I guess that solution has to be t is equal to 3. Right, so this log 2 of a should be equal to 9. So a is 512, and the sum of digits is 8. M and n are two positive integers that satisfy the following equation. What is m plus n? Okay. Let's see. I guess here we can divide both sides by this term because I see similar expressions here. So if we divide everything by the right-hand side of the equation, we have 1 over log n of 10 plus 1 over log m of 10 times log m plus n plus 10 of 10. Cool. So now we can divide both sides by this number. And then since we're doing reciprocals, I guess actually everything is like base 10, right? So we have log of n plus log of m, it's base 10, equals log m plus n plus 10. So m times n equals m plus n plus 10. M minus 1, n minus 1 equals 11, the Simon's favorite factoring trick. M and n are positive integers. So I guess we can do 2 and 12, or 12 and 2, doesn't matter. The sum is just 14. All right, so that's the answer. U, V, W are three positive numbers that are not equal to 1. If we have the following two equations, then what's the value of log W of U? Okay. So to make it simpler, let's do some change of variables. Let's do log U of V is X, log V of W is Y, and log W of U is Z. So what do we have? Log U of V times W. So log U of V is here. Log U of W is Z 1 over Z. So it's like X plus 1 over Z. Log V of W is right here, so just Y. I equals 5. What is this? Log V of U, that's 1 over X. Log W of V, that's 1 over Y. Okay, so 1 over X plus 1 over Y equals 3. Of course, we can do the change of base, and you see the product should be 1. Okay, we're trying to find the value of Z, right? Log W of U, that's the value of Z. So let's see what we know about Z. So we know X plus Y is 5 minus 1 over Z. We also have X plus Y divided by XY is equal to 3. We also have XY is equal to 1 over Z. Now we see there's the equation for Z, right? There's 5 minus 1 over Z over 1 over Z. That equals 3. That means 1 over Z is equal to 5 over 4. So this Z is equal to 4 over 5. That's the solution. Interesting question. P and Q are two positive numbers so that they satisfy the two equations here. And basically want to find P over Q. A very interesting equation because it's not easy to deal with those expressions. They have different bases. Let's take a look. If we assume that all of them are equal to K, then what do we have? Based on the definition, P is equal to 4 to the power of K. Q is equal to 6 to the power of K. P plus Q is equal to 9 to the power of K. But notice that 4 times 9 is equal to 6 squared. So P times P plus Q, that's 36 to the power of K. That's 6 to K squared, that's Q squared. So we have P squared plus PQ minus Q squared is equal to 0. We're looking for P over Q. So let's divide everything by Q squared. P and Q are positive numbers, so P over Q should be positive. So I guess we need to do root 1 plus minus 1 plus root 5 divided by 2. There's a negative solution, but we don't want that. Okay, so we have M is 5, N is 1, K is, ooh, that's a different K. Bad notation. You know, that K is totally different from the K here. Anyway, so the sum is 8. All right, next one. This is question 19. Okay. We saw a similar question before. You know, the log U of V, V of W, W of U. I guess those ones quite similar. Let's take a look. Again, let's do change of variable. This time, let's do log X of Y is A, log Y of Z is B, log Z of A, log Z of X is C. what do we have? A plus B plus C, that's 8. We also have, what is log x of z? That's log x of y times log y of z, right? So AB. So it's like AB plus BC plus DA. That's 25/2. Of course, again, we have the product. Let's do 1. Okay, sounds like we have a cubic equation, right? From we can construct the cubic equation t to the power of 3 minus 8t squared plus 25/2 times t, and then minus 1, that equals 0. So A, B, C are 3 roots. A, B, C are 3 roots. Cool. Want to find the value of B. Okay, so it's like solving this cubic equation. Basically, there's only one practical way to solve a quadratic cubic equation, which is to just guess one of the roots. So here, t is equal to 2, that's a root. So this is t minus 2 times t squared minus 6t plus 1/2. Cool. So 2 is one root, and the other 2 roots are 3, plus something, 3 minus something. Let's see. A should be larger than or equal to 1, right? Because x is smaller than y. Y is smaller than z, so this is also larger than or equal to 1. B is smaller than 1. B is the irrational number. There are 2 roots that are greater than 1. One of them is 2, the other is the irrational number. But B is irrational, so I guess here A should be 2. 2. And B should be the irrational number there. What's that? 3 plus square root of 34 divided by 2. This it's like a 3 plus this one, but if you want to put 3 on top, then 6. Okay. So we take the sum, 6 plus 34 plus 2. That's 42. Okay. Ooh, that's the last one. All right, then that's it. Hope you guys enjoyed it, and good luck on the AMC12 test. See you guys soon.